Video, I want to talk about how to find the initial or final amount in a word problem on exponential growth or decay. So all of these problems actually deal with continuous exponential growth or decay, and so the model function that we can use is that the amount as a function of time is equal to p, which is the initial amount, or it's like the principal in money, but whatever the initial amount is, times e to the rt. And so this is the initial amount. And then R is the rate that it's growing. So it's often called, in decay, it's often called a decay rate parameter, but the R is the rate. Okay, so P times e to the RT is how we figure out anything for a continuous model. So this one says a mass of a radioactive substance follows a continuous exponential decay model with a decay rate parameter of 15% per day. The initial mass is 5.8 kilograms. Find the mass after 7 days. So basically what we're going to do is we're just going to plug this into our function. The amount as a function of time is equal to p, which is the initial amount, so 5.8 times e, which is just a number, times the rate. So the decay rate parameter is 15% per day. So this is decay, which means that we're going down by 15% every day. So it's negative 0.15, which is 15% as a decimal, times t. Okay, so decay always goes down, so it's negative, and growth always goes up, so it's positive. Okay, so now we want to find the mass after 7 days. So A of 7 is equal to 5.8 times e to the negative 0.15 times 7, and then we just need to put that in our calculator. So we would get 5.8 times, let me do this backwards of that. Let's do negative 0.15 times 7 e to that power, and then times 5.8. So our final answer should be 2.03 if we round to 2 decimal places. So 2.03 kilograms is the mass after 7 days. And that's how you find an initial or final amount in a word problem on exponential growth or decay. And this is really specifically talking about continuous growth or decay.